So we're going to do an example where we have the x-intercepts and a point are given to us. So if that's the case, then we want to know which form is going to be the most helpful to use. So the form that uses the x-intercepts is intercept form. So that's the form that would be most beneficial when we're writing this equation. So intercept form, I'm just going to rewrite it here, is y equals a times x minus p times x minus q, where p and q are the x-intercepts. So then we want to know, well, what information do we know about this equation and what information do we need to know? Well, if I'm going to plug in all the information that I'm given an x value for the x-intercept and another x value for the x-intercept. So 1 and -2 are my x-intercepts, and my point is just an xy point on the graph. So if I were to fill in this information, y is 12 equals, we don't know a, so that's our unknown value. But we do know our x value is 2, so I'm going to plug in 2 for both of these x's. And then we know our p and q, the two x-intercepts. It doesn't matter which order you write them in. So I'm just going to put them in order, x minus 1, and then we already filled in that x, and our q, our second intercept, is -2. Notice that I had to keep the minuses. If you see them in the equation, they have to stay there. Now we are just going to simplify and solve for a. So that's kind of what we have already started here. I'm going to continue that in part C. We've plugged in the values that we know. Now we're going to solve for a. So we have 12 equals a times 2 minus 1 is 1, and 2 minus -2 is really 2 plus 2. And we're just going to continue that process. 1 times 4. So this gives us 12 equals, I'm going to write this as 4a. Then divide by 4 on each side. And we get that 3 is a. So we found our unknown variable. Now what we can do is, I'm going to take you back up to the top. All we have to do now is plug in a, which we found was 3, and our two x-intercepts that we were already told were 1 and -2. So that ended up being x plus 2. All right, so if I'm going to write this in intercept form, I'll break that down for you one more time. So y equals a times x minus p times x minus q. We found that a is 3. And we were told the x-intercepts. X, I'm going to go back up here so I can show you. One of the x-intercepts was 1, so that would be x minus 1. And the other x-intercept was -2. So minus -2. And then when we simplify that, that's where the plus 2 came from. Okay, so that's our equation in intercept form. Now this also says to write it in standard form. So if we were going to write this in standard form, what we would have to do is just box those two factors, those two sets of parentheses, and then just write it in standard form. So really all we're doing here is multiplying out all of those parentheses. So that would be 3 times. Now what I'm going to do is box out, or use the box method to find what this is. So x minus 1 and x plus 2. So that's x squared minus x plus 2x and minus 2. All right, so if I simplify that, that's x squared, -x plus 2x is plus x, and then minus 2. So in my parentheses up here, basically what I've done is I've taken this, and I'm going to rewrite it as x squared plus x minus 2. Okay. Now I can distribute the 3. So that would be y equals 3x squared plus 3x minus 6. And that is my new equation. Well, it's the same equation, just written a different way. So those are my equations in intercept form and standard form for this quadratic that has those x-intercepts and that particular point.